We're going to move on to graphing hyperbolas today and writing equations for hyperbolas. We have some steps that need to be followed in order to be able to graph these. So these are a little bit more involved in the graphing process. Number one, we want to make sure that we have the equation in standard form. And so we're going to look at number one first. And I can see there that that equation is in standard form because on the right hand side of the equation is a 1. So you always want to make sure, just like in previous lessons, that we had this equation solved for 1 in order to be certain that it's in standard form. You can see from the two different forms of these equations over here that in one situation, this first one, our y squared term is after the subtraction sign. So these hyperbolas are going to have a subtraction sign in between the two fractions, whereas our ellipses that we did in 9.4 had a plus sign here. So that's how one of the ways we're going to be able to determine whether we have an equation for a hyperbola or an equation for an ellipse. So when the y squared term comes after the subtraction sign, then that's going to change some of our the way that our graph orients itself on the coordinate plane. The other possibility is our y squared term comes first and it is positive. If you notice, the a squared and the b squared, they're not going to switch sides here. It's the x squared and the y squared that could be on different sides depending on the problem we're talking about. So number one, we have it in standard form. In number two, we're going to solve for a and b. So if our a squared in number one is 16, that means our a is 4, and our b will be 2. Then we're going to use a and b to create this box shape that I'm talking about here in step 3. This box is going to be used to draw our asymptotes that are going to help us actually draw in this hyperbola. So this is definitely different. We haven't done this idea of creating this box before. So what you're going to do is you're going to look at where your a term is and where your b term is. So in this case, my a term is under my x squared and my b term is under my y squared. So this is important because this 4 units is going to be situated left and right of the vertex on the x-axis. So right here, what I'm going to do is I'm going to come from the vertex because we're assuming in each of these problems that our vertex is at 0, 0. I'm sorry, not our vertex. The center of our hyperbola is going to be right here at the origin. So I'm going to come out 4 units to the right, and I'm going to go out 4 units to the left to get my first 2 points. They're the points that are going to be on that x-axis. Then my b term, since it is situated under the y squared, that the 2 is going to be my vertical distance up and down on the y-axis. So I'm going to go up from the origin 2 units and then down 2 units as well. And so from here, I'm going to draw in a box shape. Right? I'm going to do it in yellow so you can see, I'm sorry, orange, so you can see a little bit better, but I'm going to make the length of my box up here. I'm going to just dot it in. When I get to 4, I'm going to come down, and then I'm going to do the same thing here and come back up. All right, so my box is just kind of connecting. It's like the center points on the length and the width of where those points hit. All right. I'm going to now use my ruler to draw in my asymptotes. So if I take the ruler and what I'm doing is just crisscrossing across the box. So corner to corner, there's 1. All right, so corner to corner, making sure that I am going through the center as well. At the origin. Okay, and so those are my asymptotes for this one. And then what I need to do now is, after I've gotten the box drawn in to make my asymptotes, I'm now down at step 4. I'm going to determine the sign on the y squared term. So in this case, I go back up, I can see my y squared is after the subtraction sign, so my y squared is negative in this problem. Since I have a negative y squared, that means if you come down here, that what that means is I'm going to have a horizontal transverse axis. So a transverse axis is going to be the mirror that I'm going to graph my parabola, my hyperbola around. In this case, it's going to be horizontal. So it's going to run horizontally directly through the center of this hyperbola. In this case, because we're working with hyperbolas that have a center at 0, 0, the origin, my horizontal transverse axis is actually going to be the x-axis. So I can just draw that in right here on the x-axis, and I'm just going to label it, HTA, horizontal transverse axis. So now I've got, that's the mirror, so that's where the vertices of this hyperbola are going to sit. All right, so now that I have that in there, I've drawn the transverse axis, I'm going to use it to mirror, and then I've graphed my asymptotes, my transverse axis, I've done all that. Now I'm going to actually put in the actual graph. All right, so I'm at step 6. So using the asymptotes and the transverse axis, I'm going to draw in my hyperbola. Right, so it's going to follow the asymptotes. It's going to kind of curve with those. I know that it's going to be sitting on the my vertices are these points here because I have a horizontal transverse axis, because that's my mirror. If I drew it the other way with the vertices at 2 and 2 and -2, if I drew it that way, I'm going the wrong direction. That wouldn't be a transverse axis, that was the y axis, and I don't want that. I want it to be the x-axis. So that's how I know that they're going to open left and right instead of up and down. All right, they also want us to calculate the foci. So foci is just the plural of focus. We talked about that when we did our ellipse. And so in this case, if you have a hyperbola, the equation for the foci is c squared equals a squared plus b squared. When we worked with this before, when we did ellipses, it was a squared minus b squared. So this has a sign change in the middle of it. It's very similar, so keep that in mind so that you don't get those confused. All right, so we don't know c squared, but we do know that a squared is 16, and we know b squared is 4. And so c squared is going to be plus or minus the square root of 20. All right, and that is roughly 2 square roots of 5, which is roughly 4.5. All right, so I can put in my foci at 4.5. So remember, my foci are going to land are going to be in the middle, just like when we graphed our parabolas. They're going to sit inside the graph. So we want to come out here at 4.5 and dot in. And same thing here. Just label it with a lowercase f. And then the actual points, if we were to write them as coordinate pairs, would be plus or minus either square root of 20, or 2 squares of 5, or we can just call it plus or minus 4.5. All right, so the points for the vertices are going to lie for the foci are going to lie right here. If they wanted us to write in the vertices in coordinate pair form, that's the points right here. Remember the vertex. The vertex is the lowest or the highest point. In this case, it's the left and rightmost points on the parabola. So we're looking at these points right here that we used to graph. If they ask us to write those in coordinate pair form, in this particular case, it would be plus or minus 4, and 0 would be the y coordinate for that. Okay, so positive 4, 0 over here, negative 4, 0 on this side. All right, so we've graphed the equation. They asked us to do that. We've identified the vertices. We've identified the foci. They also want us to write an equation for the asymptotes. And so that is this last step down here, number 8, calculate the asymptotes. If you have a horizontal transverse axis like we do, then the equation to come up with the actual equations for those asymptotes, so we're talking about an equation for these two lines here, is it going to be plus or minus the b coordinate, which here is 2, over the a, which is 4. And then, of course, reduced would give you asymptotes at plus or minus 1/2. So these are your asymptotes. And you can see that if you go to the origin, you can go up 1 and to the right 2. Or in this case, you could go up 2 and to the right 4. And that shows you that that is a point on the line, that yellow line there. You could do the same thing from here. You could go up 2 to the left. I'm sorry, yeah, up 2 to the left 4. And you would get the same thing. You get a point lying on this line. So the y equals plus or minus 1/2. Actually, I left out the x here. That's actually an equation for this line. So when you write it out, you would write it out as y equals plus or minus 1/2 x. So let's try doing the same thing with number 3. Number 3 has the reversed standard form equation. So in this case, in number 3, y squared is positive. We've got the y squared term first. We can see it's in standard form because it's solved for y. And then if I solve for a and b, again, this term here is my a squared. This term here is my b squared. So a is 5 and b is 2. All right, we're going to use those two numbers to create the box that's going to help us draw our asymptote. So my a squared term of 5, my a term of 5 rather, is underneath the y term. So that means that I'm going to go to the y-axis and I'm going to go up 5 and I'm going to go down 5. And then my x term is over top of the b, so that's 2. That means I'm going to go to the x-axis and go to the right and to the left 2 units. So now I'm going to get a box that's a little bit more vertical in nature. All right, I'm going to connect each of those dots to make a box with a little dotted line. All right, so there's my box. I'm going to get my ruler, and I'm going to connect through the center. I'm going to go corner to corner on the box. There's one, and then my second one. All right, so there are my asymptotes. The sign on my y squared, so I'm on step 4, is positive. So this means I have a vertical transverse axis, which in this case is the y-axis. So that's going to be this right here. So it's the y-axis because the center of my hyperbola is the origin, 0, 0. So now I have everything I need to know in order to go ahead and graph this. If my transverse axis, the mirror that I'm making this asymptote, this hyperbola around, is the y-axis, then that means that this is going to open up and down. Right, so this is my vertex then, right here, this point I used from A, this 5. So I'm going to go start there, and I'm going to go up, and then I'm going to come down here and start there at that vertex again and come down. So now I'm going to calculate the foci using our formula, c squared equals a squared plus b squared. My a squared is 25, my b squared is 4. So this means that I have a foci at plus or minus the square root of 29, which is approximately 5.5. So that's, again, those are going to be inside the hyperbola. So I'm going to come up here at about 5.5, which is a little tight because of how they numbered. Just get it as close as you can, label it with an F, and then I need to, so there's my foci then, and if I'm going to write them out as a coordinate pair, now I can see that my x coordinate is going to be 0, my y coordinate will be plus or minus 5.5, or you could write it as plus or minus the square root of 29. It just helps to plug it into the calculator and get that approximation of 5.5 in order to put it on the actual graph. Okay, so these are your foci. They want us to find the vertices, which we've already calculated those. We've already graphed it in. It's where the bottommost point here and the topmost point here, which we know that is lying at 0, positive 5, and 0, negative 5. So if we were to write those out in coordinate pair form, just write it out over here, that would be 0 plus or minus 5. So there are vertices for this one. Foci here. And then they want us to calculate the lines for the asymptotes. So again, that's number 8 here. If we're going to calculate the asymptotes, in this case we have a vertical transverse axis, so that means our equations are going to be y equals plus or minus a over b x. So y equals plus or minus, then our a is 5, our b is 2, and then we'll stick the x on there. So those are the two equations, y equals 5 halves x or y equals negative 5 halves x. If you went to the origin and you counted up 5 to the right 2, you would get a point on this yellow line. And you would do the same thing if you started at the origin, you counted up 5 and to the left 2. You would get a point on this other asymptote. Now let's move to the back of the sheet where they give you the foci and the vertices, and they want you to write an equation for the hyperbola. So in this case, we've got to first look at those vertices and see whether they lie on the x-axis or the y-axis, because that's going to tell us what type of transverse axis we have, whether it's horizontal or vertical. So in number 7 here, we can see that, and I'm just kind of drawing a visual out. You don't have to do this if you can see it without doing this, but if we were to draw that out, you can see that your vertices are going to be at positive 4 and negative 4 here. And so that means that these are the bottommost point of your hyperbola, so they're going to open this direction, left and right. So that lets you know that you have a horizontal transverse axis in this problem. If we have a horizontal transverse axis, if you go back and look through the steps that we wrote down, horizontal transverse axis means that the y term is negative. All right, so our y squared term is going to be negative in this case. So that tells us that we are dealing with the standard form equation that has the x squared term first and the y squared term second. All right. The next thing we have is our foci. We can see that those are also lying on the x-axis as well at 6 and negative 6. All right, so that's going to help us here in a minute. Once we have this in place, once we know our vertices are at 4 and negative 4, that means we know that our a term is 4, and so our a squared term is 16. So I'm going to go ahead and put that in. The only thing we are lacking then in order to finish this equation off is our b squared. And we can use the formula for our foci in order to solve for b squared. So this is our formula. We know that c squared is our focus, so that's 6. So that means our c squared is going to be 6 squared, or 36. We have our a squared. We need our b squared. All right, so after you do the math and the algebra here, we'll end up with a b squared of 20. And so we take that number. We don't need to solve for b because we don't need b. We need a b squared. That's what we need in order to fill in this formula right here. So then from there, we're just going to plug in that b squared. We have our standard form equation for this particular set of parameters. You can see in number 8 that we have the reverse situation. In this situation, our foci are lying on the y-axis at 8 and negative 8. So this means that we have a vertical transverse axis. If we have a vertical transverse axis, then according to our notes, that means that our y term is positive. So our y squared term is positive, and because of that, we know that we are dealing with the standard equation where the y squared is the first term. So y squared over a squared minus x squared over b squared. So we have our vertices at 7 and -7 on the y-axis. So that means that our a term is 7. We square it and we get 49. So y squared over 49 minus x squared over b squared equals 1. So once again, we're looking for our b squared term. All right, so now we're ready to calculate our b squared using our equation for the foci. If our foci are at 8 and -8, that means that c squared is 64, a squared is 49, and we want to calculate b squared. All right, so we can stop here at b squared equals 15 because that's the term we need. We don't need b, we need b squared. So we can just stop right there and then fill in the remainder of our formula. And here we have the standard form equation for the set of parameters listed out for us in number 8. All right, and then 11 through 13 are equations that they want us to graph and determine whether they're a parabola, an ellipse, or a hyperbola. So without even graphing these, you know a good bit about each of these. If we're looking here at number 11, we can see we have an x squared and a y squared term. So this means we're either dealing with a circle or dealing with an ellipse. So remember, the ellipse is just a squished circle. So once we know that, we can look at the coefficients. So the coefficient here on the x squared and the y squared are not the same. So that means the units that from the origin on the x and y axis are different. They're not going to be the same distance from the origin all the way around this shape. So then this lets us know that we are definitely dealing with an ellipse here instead of a circle. Now to actually graph it, we're going to have to go back and put this in standard form before we can do anything with it. But let's move over to 12 and look at that one. Here we have an x squared term, but not a y squared. So this is not linear. You know, if it were linear, we wouldn't have the x squared term. This is a quadratic. Because the x is squared instead of the y, then this lets us know that we're dealing with a parabola that's opening up or down. So because the x squared is the x is squared and the y is not, that's how we know we're dealing with a parabola. The fact that the x is this term that is squared instead of the y lets us know that we're dealing with either a parabola opening up or a parabola opening down, which we'll get to when we actually put that in standard form. And then in 13, we have an x squared, we have a y squared, and I failed to mention this over here on number 11, but the other thing that lets us know we're dealing with either an ellipse or a circle is this plus sign. Here we have x squared and y squared. So the next thing we look at is the sign. Since it's a subtraction sign instead of an addition sign, this tells us that we're dealing with a hyperbola. Then we need to go back and put all of these into standard form. So go ahead and pause the video and work on putting those in standard form, and then start the video back up and we'll graph them. Okay, so on 11, we're going to graph this ellipse. On the ellipses and the circles, the a squared follows the bigger number. So in this case, your a squared is 25, the b squared is 4. It doesn't matter a whole lot, because when you go to graph it, so here my a is 5, my b is 2 then. When I go to graph it, this means that my a is going to be on the y-axis because it's underneath the y squared term. This just, the reason we switch back and forth here depending on which number is bigger is because the a value lets you know what your major axis is versus your minor axis. Major meaning the one that's going to run through the longer side of the ellipse, minor the shorter side. But in practicality, really we're just looking and saying, okay, A is 5, so that's going to be, it's under my y squared term, so that's going to be on the y-axis. So I'm going to put that at positive 5 and negative 5. All right, so that's going to, if we connected those dots, that would be our major axis. And then the b squared, or the b term is 2, so I'm going to come out from the origin to the left and right 2 units. And that would be my minor axis if I were to connect those dots. And then I'm just going to circle those into an ellipse as best as possible. Number 12, standard form here is my y being isolated. So from this point, then I'm going to use my x, y table. And if I plug in 2 for x, I'm going to get y of negative 25, which isn't going to fall on this graph. So we can kind of see that this thing is going to be dropping pretty quickly. It's going to be a pretty narrow parabola. I'm actually looking at this and realizing I did what I solved for here was not standard form for the parabola. I solved this equation for standard form as a quadratic. So it is a quadratic formula. It's also a parabola. But that's why it's not graphing easily. So I'm going to back up and re-solve this for parabola standard form, and then this will graph really nicely. So standard form for the parabola, like we talked about in section 2, is having the squared term solved for. So this works a lot better. If I plug in negative 4 for y here, I get a positive 1. Negative 1/4 times negative 4 is going to give me positive 1, which gives me an x square root of 1, which is going to give me 1 when I take the square root of that. So that allows me to plug in my vertex, 0, 0, and put in 1, negative 1. And then here, because it's a parabola, and I can see that it's going to be opening down, all right, my p-value right here is negative, so that allows me to rule out this opening upward, and I know it's going to open downward, and use this as my mirror to come over here and get my third point, and then draw that parabola in. All right, and then last we have our hyperbola, which is what we've been working on this whole lesson. I have my a term, a squared term is 4, so my a is 2. My b squared term is 25, so my b is 5. Again, I've got a negative y squared term, so that means I'm going to have a horizontal transverse axis. In this case, it's going to be right here at the x-axis. Okay, I'm going to make my box. The 5 is going to lie on the y-axis here and here. The 2 will be on my x-axis, and then I'll dot the box in and use my ruler to make my asymptotes, going through the center, connecting those corners. And then keeping in mind that I have a horizontal transverse axis, so that lets me know that I'm opening left and right. Here's the foci, or the vertex for my right side. Here's the vertex for my left side. And there's my graph.